Okay, so we have a question here from a past SimSec paper that reads: an electrolytic cell was set up to determine the value of the Avogadro's constant as shown. This is the usual electrolytic cell setup. A current of 1.90 amps was passed through aqueous copper 2 sulfate for 50 minutes. And you're told that the mass of the cathode changed from 70.14 grams to 71.97 grams. And you're asked here to calculate the Avogadro constant. So, firstly, we're supposed to be able to determine the current, the charge that was passed, the coulombs that was passed through the electrolytic cell. And we do so by multiplying our current and our time, but the time has to be in seconds. So here we are told that a current of 1.90 was passed for 50 minutes. So we have 50 minutes times 60 seconds in each minute, and we get 5,700 coulombs. So this is the charge that we passed. And when we passed that charge, we are told that our copper, so the mass of copper changed from 71.97 to it changed from 70.14 rather to 71.97. So that's a change of 1.83 grams. So in other words, in order for us to deposit 1.83 grams of copper, we required 5,700 coulombs. So we can create an equation there and say, in order to deposit 1.83 grams of copper, you require 5,700 coulombs. So this is what our experiment showed us. It's an experimental fact. So we can then infer from this that how about if you want to deposit 1 mole of copper, how much charge do you require? So 1 mole of copper is 63, if you check with your periodic table, 0.5 grams. So how much in terms of charge? Of course you get more. And if you do the proportion there, 63.5 grams over 1.83 times 5,700 coulombs, you get 197,986.9 coulombs. So this is what you require in order to deposit 1 mole of copper. But we also know that in order for you to deposit 1 mole of copper, the stoichiometric equation looks like this: Cu 2 plus 2 electrons to give us Cu. So you require 2 moles of electrons in order to deposit 1 mole of copper. So this charge that we said is the charge that is required to deposit 1 mole of copper should be equal to 2 moles of electrons. Should be equal to 2 moles of electrons. So we can say, according to this, 2 moles of electrons have a charge of 197,986.9 coulombs. So we are simply equating what we inferred from the experiment and the fact that every time you deposit 1 mole of copper, you would have provided 2 moles of electrons, or 2 E, according to this equation. So we can now speculate or we can figure out now the charge of 1 mole of electrons. How about 1 mole? 1 mole electrons have a charge of of course you get less, and this would be equal to 1 over 2 times 197.786.9 coulombs. So the charge on 1 mole of electrons is equal to 98,893 so this would be the charge on 1 mole of electrons. But we also know the charge on 1 electron. We know the charge on 1 electron. 1 electron has a charge of 1.6 times 10 to the power negative 19 coulombs. So if we divide the charge that we have for 1 mole of electrons with the charge of 1 electron, then we can figure out how many electrons were there altogether. So we have this equation that says L is equal to F E, where L is our Avogadro's constant, right? This would be the charge that we passed, the charge on 1 mole of electrons, and this would be the charge on 1 electron. This is the charge on 1 mole of electrons. This is the charge on 1 electron. So if we do the division there, we have our 98,893 divided by 1.6 times 10 to the power negative 19. And if you divide there, you would get 6.18 times 10 to the power 23. And this is how we determine the Avogadro's constant L using the electrolytic method. So I hope this was helpful.